Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3, because again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I have log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2, and I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution. All right. So in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2, because 100 to the power of 1 is 100, and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. If I have something in the form log a to the power of b, I can move this exponent of b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301.